these are notes 7.4. I'm going to do some matrix operations here. First couple is pretty easy. Multiplication gets a little complicated, but you guys can do very well with it. Okay, so first of all, a matrix is classified by its dimensions. Okay, we have rows by columns. So this one has one row by 1, 2, 3, 4, 5 columns. So we call that a 1 by 5 matrix. This one has 1, 2, 3, 4 rows and one column, so it's a 4 by 1 matrix. This one has 3 rows and 2 columns. This one has 2 rows and 2 columns. Okay, so that's how we classify the matrices. Now, to be able to add and subtract matrices, they have to be the same dimensions. Okay, so this is a 2 by 2, this is a 2 by 2. Then you just add the corresponding entries. So 5 plus -4 is 1. -6 plus 6 is 0. 8 plus 8 is 16. 9 plus -3 is 6. So there's our matrix when we add those together. Once again, add these together. 2 plus -6 would be -4, 5, 8, and 20. Okay, now these I can't add together because I can't, like I could add this and this and this and this, but there's nothing to add on the end there. So this is not possible. Okay, we can't add those together because they're not the same sizes. Okay, when we subtract, do the same thing, just subtract. If you want to, you could turn this to addition and change all these signs here, or just subtract. So 5 minus -3 would be +3, would be -2. 6 minus 2 is 4. 2 minus 5 is -3. 4 minus -8 would be 12. Okay, here I cannot subtract them because they're not the same sizes. And here, if I add -5 plus 5 is 0, 2 plus -2 is 0, -1 plus 1 is 0, and 0, and 0, and 0. Okay? Now, if we add, you remember, if I take some number and add 0 to it, I get the same number back. Okay? Remember, these would be the, this is the additive inverse sort of thing. Well, that's the identity. If I add a plus a -a, I get the identity back, right? So a and -a are inverses of each other, sort of thing. Like 2 plus -2 are inverses. So this is the additive inverse for a matrix. Okay, just the opposite of it. Okay. Also, pretty simple to multiply by a scalar, by a number in front. All you do is just take 5 and multiply by all those numbers there. So 5 times 2 is 10, -15, 0, and 20. 3/4 times 20 be 15. 3/4 times 36 be 36 over 4 is 9 times 3 is 27. 3, 9, and -12. So it's a matter of just multiplying together. Okay, now where it gets a little tougher is when we do this matrix multiplication. To be able to multiply things together, so say the first matrix is a m by n matrix. So this one here, for example, is a 2 by 3 matrix. And this one is a 3 by 2 matrix. Okay? To be able to multiply this together, these two numbers have to be the same. If those are not the same, then I cannot multiply those together. So here, these are both 3s. I can multiply them together. We're good. My answer is going to be the m by k. Okay, that's my resulting matrix. So I know my resulting matrix, when I multiply them together, is going to be a 2 by 2. So a 2 by 2. And you'll see why I put some longer lines there in just a minute. Okay? Now this is how we work it out. Okay, this here is in the first row, first column. So I'm going to take the first row and the first column, and this is what I'm going to do. I'm going to take the -3 times -6, and I'm going to add to that the next one, 4 times 2. And I'm going to add to that the next multiplication. Okay, so I'm going to take, this is in the first row, first column, so I'm going to take the first row times the first column. So that's 18 plus 8 plus 6. Okay, so that, and then add it all together. So 18 plus 8 is 36, so 42. Okay, so I'm multiplying together there. Okay, this one here is in the first row, second column. I'm going to do first row in the second column here. So I'm going to take negative 3 times 4, then 4 times 3, and then 2 times negative 2. Okay, so I got negative 12 plus 12 minus 4 would be negative 4. Okay, this one here is the second row in the first column. So I'm going to take second row and first column. So we have 5 times negative 6, 0 times 2, and 4 times 3. So that's negative 30 plus 0 plus 12 would be negative 18. Okay, this one here is in the second row in the second column. So 5 times 4, 0 times 3, 4 times negative 2. That'd be 20 plus 0 minus 8 would be 12. Okay, so that's how you multiply matrices together. This would be my resulting matrix. Okay. Okay, so notice here, I just kind of switched these two around. So we know that in regular numbers, 2 times 3 is the same as 3 times 2, right? The commutative property. Okay, we'll see, does that commutative property hold here for matrices as well? So let's multiply them together. So this is a 2 by 2 and a 2 by 2. So the inside numbers are the same. We can do it. Our result's going to be a 2 by 2. Okay, so first row, first column, be 1 times 2, and then 3 times 10. So be 32. This one here, first row, second column. So 1 times 5, 3 times negative 3. So be 5 minus 9 would be negative 4. First row, second column. Second row, first column. Negative 2 times 2. And 4 times 5. 4 times 10, I mean. Would be negative 4 plus 40 would be 36. And second row, second column. Second row, second column. So negative 2 times 5 for negative 3. Okay, so be negative 10 and negative 12 give you negative 22. Now, let's say I just switch these two around, okay, and multiply this one times that one. Once again, it's a 2 by 2. So 2 times 1 and 5 times negative 2. Be 2 and negative 10 would be 8. We can already see they're not the same, right? Okay, this one here, first row, second column. So 2 times 3 and 5 times 4 be 26. This and this, 10 times 1 plus negative 3 times negative 2, be 10 plus 6 is 16, and then 10 times 3 and negative 3 times 4. So be 30 minus 12 is 18. Okay, so you notice that commutative property holds for regular numbers, right? But it does not hold for matrices. Okay, so if we think about applying this a little bit, suppose you are the manager of an electronics store, and one day you receive the following products from two distributors. Wholesale Enterprise. Okay, Wholesale Enterprise delivers 2 cell phones, 5 DVDs, and 5 video games. And then the other place, Discount Distributors, has 4 cell phones, 5 DVDs, and 6 video games. Okay, so let's organize this into a matrix here. So let's do Wholesale Enterprise on the top, and we'll do the Discount Distributors on the bottom here. Okay, so the first one here will be the cell phone. So Wholesale Enterprise had 2 cell phones. The other one had 4 cell phones. And then DVDs were 7 and 6. And then video games was 5 and 9. Okay, so that's what we got here. Okay, so part B, what's the size of this matrix? It's a 2 by 3. Okay, another day, there was a shipment that came in, which was this one, which is, set up the same way. So I'm going to add those together, combine shipments together. So altogether, I got 5 cell phones from Warehouse Wholesale Enterprise. And then 7 plus 12 is 19. I got 19 DVDs from them, and a total of 15 video games from them. And then the Discount Distributors, I got 4 plus 15 makes 19 cell phones, and 17 DVDs, and 17 video games. Okay. D, this matrix describes what was sold from the shipments. What's the remaining inventories? Okay, so we had this come in. This is what was sold. So we're going to subtract the 2. What we have left would be 5 minus 2 would be 3 of those, 9 of those, 0 of those left, 10 of those, 10 of those, and 7 of those. So we did some subtraction there to see what was remaining. Suppose each cell phone costs $120. The DVD costs $18, and the video game costs $9. How much did the first shipment cost? So we're just looking at this first shipment. Okay, so if we set it up like this, okay, so we want to multiply it by this matrix, 120, 18, and 9. So you notice when we multiply, it's going to be first row, first column, right? So it'd be 2. So for Discount Distributors, sorry, this one, Wholesale Enterprise, the cell phones cost this, DVDs cost this, and video games cost this. Okay, and we'll add all those together then. So notice this is a 2 by 3 matrix. This is a 3 by 1 matrix. Our answer is we can multiply them together because there's 3 and 3 in the middle, and the answer is going to be a 2 by 1. Well, I should probably write it out. Okay, so 2 times 120 plus 7 times 18 plus 5 times 9. Okay. So for Warehouse Enterprise, if we multiply those all together, and add them, it comes up to be $411. And then for Discount Distributors, 4 cell phones at $120, okay, plus 6 DVDs at $18, and 9 video games at $9. Multiply and add all that together, comes up to be $669. Okay, so that's how you can see how the multiplying together can be helpful. Okay, we'll do one more here. A contractor builds three kinds of houses, X, Y, and Z, so three kinds of houses, with a choice of two styles, either a colonial or a ranch. Matrix A is the number of each kind they plan to build. So this kind of house, X, Y, and Z, so this kind of house they can either make into a colonial or a ranch, and this kind colonial or ranch, or this kind colonial or ranch. The materials needed depends on the style of the house, shown in B. Okay, so here's the materials. To build a colonial, they would need 10 units, whatever it is, of concrete, and lumber, 2 units, no brick, and 2 shingles. For a ranch, and you can see what's needed for a ranch home. Matrix C gives the cost of each of these. So the concrete is $20 a unit, lumber $180, brick $60, shingles and $25. Okay, so let's answer these questions. What is the total cost of material for all houses of each model? So first we're going to need to know how much of these things are needed, right? So we're going to take this times this. A times B will give us how much is needed. Okay, so this is a 3 by 2. This is a 2 by 4. We can multiply them together. Answer is going to be a 3 by 4. Okay, so this will tell us how much material is needed. Okay, so if we take first row, first column, this is going to be 0, and 30 times 50 would be 1,500. So this is our concrete needs, right? Okay, we'll keep going across. So this is our colonial, right? Okay, our colonial for lumber, right? And then our ranch. Okay, so anyway, multiply 0 and 30 would be 30, and 0 and 600, add those together, be 0 and 60. Okay, so that's for our Model X, right? So for Model X, that's what's needed as far as concrete and lumber and brick and shingle. Okay, let's go Model Y. So it'll be 100 and 2 would be, 1,000 would be 1,100. And then 20 and 20 make 40. And 0 and 400. And 20 and 40 make 60. Okay, and then for Model Z, how much is needed? 200 and 1,000 make 1,200. 40 and 20 make 60. 0, 400. And 20 and 80. Okay, so this is how much material is needed, right? How much of this? Now, to find the actual cost, I have to take this and I have to multiply it by the cost jet. Okay? Yeah, so I'm going to kind of go into here, and I'll do B a little bit later. So do the concrete costs, right? 20, 180, 60, and 25. Okay. Notice this is a 3 by 4, and this is a 4 by 1. My answer is going to be a 3 by 1. Okay. And if you do all this, that, and that, and multiply it all together, that comes up to be $72,900. And if I do that times that times that times that, 54,700, $50,700, and this and this, this and this, $60,800. Okay, so there is the total cost for all the houses. So when I build X, right, all these X houses, these 30 ranch houses, that's how much it's going to cost. In Y, if I build 10 colonial and 20 ranch, that's how much it's going to cost. And Z, 20 of each, that's how much it's going to cost. Okay? So for part B, how much of each type of material should be ordered? Well, all you have to do is add these right here, right? So for part B, you just add these together. So for the concrete, you're going to have 3,800 units. For the lumber, you need 130. For the brick, you need 1,400. And for the shingles, you're going to need 200. So that's how much material should be ordered. Okay? And the total cost of the materials, all you got to do is add these together, right? So if you add these all together, $188,400 would be how much all these materials will cost to build all these homes. Right, that is the basics of matrices.